Okay, I want to tell you a really interesting experiment that's been recently published in the Journal of Chemical Education by Kim, Alvarenga, Eisenberg, and Sleeper. What they do is they take a petri dish, which is made of polystyrene. It's a hydrophobic surface. And then they react oxygen in the air with the petri dish using Tesla coil. So they, using the corona energy from the Tesla coil, the oxygen in the air gets ionized, and the chain on the polymer gets disrupted, and that allows the oxygen to react with the polystyrene in the petri dish, forming a hydrophilic surface. So here's all the materials you're going to need for this. You're going to need a Tesla coil. You need some tape, a petri dish. You're going to need a petri dish that has been covered with some aluminum foil, a piece of copper wire, and a screen, metal screen, and a sticker. First step is you're going to just take the wire and you're going to try to bend it in a way where what we can do is use it to attach the Tesla coil to the screen, and that'll get connected with some duct tape. Alright, now that we've got the copper wire attached to the screen, we're going to connect it to the Tesla coil. Now on the paper they show the Tesla coil has the tip removed. We found that you don't need to do that. And they do say that in the paper that doesn't need to be removed. It's just much easier just to go ahead and tape that directly onto the tip. Alright, now that you've got the screen attached to the Tesla coil, it's convenient to set it up on a ring stand and a clamp so that you can easily move this up and down as needed. We'll get to that in a second. We're going to now prepare our petri dish, and what we'll do is we're going to take a sticker, and we use the large felt type stickers. I'm going to go ahead and see if I can't take the center out. We found the larger sticker works well. It's difficult to get into these nooks and crannies when you're doing the hydroglyphics effect. But nevertheless, we're gonna try this sticker here. I'm just gonna place it down on the petri dish, and I'm gonna push it flat. I don't want to do it too flat or press it down too hard, because I'm going to need to remove this sticker later. And if it gets really hot, which it will when I'm doing the corona discharge, the sticker sticks really good and we want to get that off later. But I do want to look at the other side and try to make sure there's no air bubbles underneath the sticker, between the sticker and the petri dish. Now when you've got that set, we're going to set this on top of the petri dish that's been covered with aluminum foil. And now we can lower the screen from the Tesla coil, and I put it right down on the sticker because that sticker's pretty thick. Okay, I make sure it's put into place here, and then we'll just turn the Tesla coil on. Now as the Tesla coil's on, it's creating a corona discharge between the screen and the plastic on the petri dish, allowing oxygen from the air to react with the plastic in the petri dish, causing that portion of the petri dish to become hydrophobic. After about 15 to 20 seconds, you can go ahead and turn the petri dish maybe a quarter of a turn and run it again. Sometimes I take, while the Tesla coil is running, I'll take a marker and push the screen down so as to get a closer distance between the screen and the plastic on the petri dish. It just seems to help to cook things a little better, so to speak. Alright, after allowing the corona discharge to interact with the plastic on the Petri dish, it's sometimes we find useful to go ahead and use the Tesla coil, the tip of the Tesla coil with the screen and the wire removed, to sort of use the tip in these fine portions here where it's difficult to get the corona discharge from the screen to the Petri dish. And we're going to go ahead and do that here real quick. So here I'm using the Tesla coil to get some of these tiny nooks and crannies. You don't want to run it too long, because doing so will cause the Petri dish to melt. Now, once you have satisfactorily allowed the corona discharge to interact with the portion of the Petri dish that is not protected by the sticker, these portions of the Petri dish should be polar, hydrophilic, whereas the part that's protected by the sticker should be hydrophobic. So we're going to remove this with a pair of tweezers. This takes a little while. And this takes quite a while sometimes. Just be patient. This is the authors say this is the part of the experiment that generally takes the most time. You can see I got a little bit of sticker caught to the Petri dish there. Alright, let's see how good a job this did. One interesting experiment that you can do is just simply blow onto the dish itself, and you can see the pattern formed. Isn't that beautiful? That's just crazy. Let's look at that again. Tell you what, the kids at science camp are going to love this. Now if we go over here to get some water in the dish, I'm going to add some water from this spigot here, and we'll place this down on the desktop. We got just a little too much. I'm going to pour a little bit out. And look at that. You can see the pattern of the flower because the portion of the Petri dish that interacted with the corona discharge is now polar and hydrophilic, and so that's where the water is going to stick, whereas the portion of the Petri dish that was protected by the sticker, that is hydrophobic, and the water doesn't want to go there. Beautiful way to show kids about hydrophobicity and hydrophilicity.